Good morning, dear students. Today we will going to start our new chapter, Light, with our new worksheet 54. Okay, and in this chapter we will study in this particular worksheet we will study about the reflection of light and spherical mirror. Okay, what is reflection of light and spherical mirror? Can you imagine that we can see anything without light? No, we can't see anything without light. See, if you are somewhere in a dark room, are you able to see the things? No, we will not be able to see things at all without light. So, light play a very important role in our life. Light is a form of energy that enable us to see. This is the only energy through which we will be able to see the objects around us. Properties of light: it does not require any medium. What are the properties of light? First, it does not require any medium, and speed of light is maximum in the vacuum, which is 3 into 10 raised to power 8 meter per second. This is the speed of light in vacuum. It's very high. Maximum. Okay. Reflection of light: bouncing back of the light when it strikes on the polished surface like mirror is called reflection of light, right? Just see this is the surface of mirror. This is polished from one side, and this is the pathway of light. This light strike to this surface and reflected back. Okay, this is the way the light bounces and through a polished surface. Let's see about the spherical mirrors. See, this is the reflecting surface. This is our concave mirror. Okay, see, this is our concave mirror, and this is the polished surface of this concave mirror. This is its reflecting surface, and this is polished surface. Okay, so, and it converge all the light rays passes through it to its focus. So that is why it is called as converging mirror, as it focus all light ray to a point. Likewise, if we say another part of our spherical mirror, we have convex mirror. This is called divergent mirror, means it spreads the light. Okay, and this is its reflecting surface, and this is polished surface. Okay, if you see, they both are the part of your spherical mirror. How? If I take this and this over here, if I take polished surface, means this is, if I take convex mirror here and concave mirror here, so this is the way. This is convex mirror and concave mirror, through which this is we have concave, and this is we have convex mirror. And if you just see through it, this form completely a spherical mirror. Okay, a polished surface through which a mirror reflects most of the light falling on it. You are already familiar with the laws of reflection of light. Like, which are the law of reflection of light? There are two laws. First of all, for that you have to just go through this figure, which clearly show you that this is, if I say the plane mirror, this is the plane mirror, this is the polished surface of the plane mirror, and if this ray incident, called incident ray, when strike to this polished surface or the mirror, this is perpendicular over this reflecting surface. When it strikes, okay, it reflect back it reflects back, and this angle of incidence I is equal to angle of reflection, right? This is called normal. This is normal and this is mirror. So first law of reflection is angle I is equal to angle R. Angle of incidence is equal to angle of reflection. See, this is the first law, that the angle of incidence is equal to the angle of reflection. And second law, we have the incident ray normal, and the point of incident reflected ray lies on the same plane. See, this reflected ray, point, normal and reflected ray, they all lies in the same plane. These are the two laws of reflection. So first of all, we just go through this. This is the spherical mirror we have, and for that, this spherical mirror, this is the polished surface of the spherical mirror. You can say this is an concave mirror. So this is the principal axis, this is center of curvature, this is radius, half of radius is called as focus, and this distance between the focus and the pole is called as focal length. Here we have the P, this is called aperture, MN. So all these points are very important while going to make this ray diagram of spherical mirror. First we have principal axis, the line joining the pole and center. This line joining the pole, this is the center and pole, this is called as principal axis. Pole, we have the center of reflecting part is called pole, right? This is the pole, this is the reflecting, the center of the reflecting surface, this is the center of reflecting surface. Aperture, this is M, and the complete, the extreme point of the periphery of spherical mirror is called aperture, right? Center of curvature, mirror is a part of spherical of a sphere, and its center is called as the center of curvature. Its center is called as center of curvature. Radius of curvature, the mirror is a part of spherical sphere, and the radius of sphere is called the radius of curvature. And focus, F is the point of convergence or diversion of light from infinity is called focus. Okay, this is the main point through the converging or diverging light from infinity is focus. So this is called as focus, and the distance between the focus and the pole is called as focal length. You see, this is your focal length. And how we will calculate this focal length? Value is r by 2. Means if we take this center of curvature, the radius of curvature from this to this, then half of this is called as focal length. Okay, so let's do this. We have, this is the ray diagram based on the concave mirror of the reflecting surface of concave mirror and convex mirror. This is concave mirror, polished from this side, this line parallel to this principal axis after reflecting passes through the focus. Okay, and one ray of light is passes through the center of curvature. In this case, I is equal to angle R. And this is the case of convex mirror. Polished surface is this, and this is your reflecting surface. This line coming parallel to this principal axis, after reflecting, if we draw back, it will comes to the focus, and another line coming from center of curvature passes to the center of curvature. And through which we can say that angle I is equal to angle R. Students, rule to make the ray diagrams are given below. For the spherical mirror, we have the ray parallel to the principal axis passes through the principal focus, R reflection focus after reflection, and vice versa. See this. This is the case of concave mirror. This ray of light parallel to this principal axis after reflecting passes through the focus. Same is the case of this convex mirror. This is the reflecting polished surface. This is the reflecting surface. This line is parallel to principal axis, and after reflecting this goes to here, and if we draw backward, it passes through the focus. Next we have the ray passing through the center of curvature reflect back to the same point. See, this is the center of curvature. If a light passes through the center of curvature, it moves back through the same center of curvature. In case of this, we have this center of curvature. If a line passes through this, it moves backward to the same point. Third, we have the ray incident obliquely at the pole reflect. If this is the pole and ray is coming obliquely, it reflect obliquely. By this way, angle I is equal to angle R. Okay, so this is the case of convex mirror. This I is equal to R. So this is all about today's worksheet. Let's do practice exercise. First we have write the rule of the images through the spherical mirror and draw the ray diagram. So you have to write down the rules as these three rules, and you have to draw these three diagrams. So first question. Second, we have draw the concave mirror and mark pole, focus, center of curvature and all. For that you have to do this question. You have to draw all these, right, and write all these points. So this is the answer of your second question. So I hope you understand it and like this, you understand this worksheet and you really saw, then you must like the video, share with your friends and subscribe the channel, and please watch all the videos till end to understand the importance of worksheet. Okay, so and you will be able to do all the questions related to that particular worksheet. Thank you students, take care.